Section 4.6 is about partial fractions, and partial fractions is part of the process of finding out what two fractions were added together to get the now rational function that we have now. All right, so I'm going to show you an example of how to do partial fractions. It says decompose x minus 11 divided by x squared minus 2x minus 3 into partial fractions. The first thing to do is we're going to want to factor our denominator, because if we factor our denominator, it's going to tell us the denominators of our two previous fractions. So factor this guy, we have to figure out what multiplies to be 3. It has different signs because of that minus sign. Bigger one is negative, so I know that x minus 3 and x plus 1 is that factored. Okay? So what we're going to do then, now it says express the factored form as a sum of two fractions using a and b as numerators and the factors as the denominators. So we're going to have x minus 11 divided by, wow, I was writing a little sideways there, let me fix that. X minus 11 divided by x minus 3, x plus 1, and that's going to equal then, a as a numerator, the direction said, over x minus 3 plus b as a numerator, x plus 1. Next step says eliminate the denominators by multiplying by the least common denominator. Well, the least common denominator out of this entire thing would be x minus 3, x plus 1. So when we multiply by those denominators, remember what we were talking about in the previous section. Section 1 of this is once we eliminate the denominators, we'll just then solve up top. I'll solve the numerators. So this doesn't need to be multiplied. I'm going to multiply everything by x minus 3, x plus 1 to eliminate the denominators. So these guys get canceled. So x minus 11. And that's what I tell my algebra kids all the time. You don't like fractions, get rid of them. Multiply by the least common denominator. Multiply this by x minus 3, x plus 1. And the x minus 3's cancel out. So I just have to say, okay, well, it's a times x plus 1. And again, same thing. Multiply this by x plus 1, x minus 3. The x plus 1's cancel out. So I'm just left over with plus b times x minus 3. Now it says the excluded values, the values that we could not have in this example because it made the denominator 0, are -1 and 3. Would you agree that makes our denominator equals 0 because of this right here? They're excluded, which means they're going to have a hole there, or you're going to have an asymptote there, right? It's undefined. By substituting each of these values into the equation, we can find the values for A. So basically what it's going to do, and B, sorry. Basically what it's going to do is going to cancel one of these guys out. It's either going to cancel the A or cancel the B out. So pick a value for X. Let's pick -1 and plug -1 anywhere you see in X. All right, what that does is now I have -1 plus 1, which is 0, and 0 times A is 0, so it cancels out. So now I can solve for B anywhere I see a -1. So now I have, let's see, -1 minus 11 is -12 equals, this became 0, plus B times -4, which would be -4B. So in this case, B is going to equal a +3. So I'm going to write it over here. B equals a +3. And in the same way, solve for A by putting in a +3 anywhere you see X. That's going to eliminate this function right here that becomes 0. And if I plug a 3 in here, I get 4a on this side equals 3 minus 11, which is a -8. Divide by 4, and I get a equals -2. So the two fractions that were added together in order to get this original fraction would be, I'm going to go back and substitute back in my a and my b. So I'm going to plug in -2 for a, so -2 all over x minus 3 plus, substitute in my 3 for b, 3 all over x plus 1. And if we add these two fractions together, we're going to get what we originally had, x minus 11 divided by x minus 3 times x plus 1, or x squared minus 2x minus 3. I'll do another example. This one was hard to write in that space that I gave myself there. It says decompose that into partial fractions. Okay, so first step, we were going to factor the denominator. We know that 5 times 2 would add up to be negative 3, with signs being opposite, bigger one being the negative in this case. So x minus 5, x plus 2. All right, and again, so we're going to break this down, and we're going to write each of these, and these are both going to be our separate fractions, or denominators of our other fractions. So I'm going to have 6x minus 2 divided by x minus 5. Okay, so x minus 5 times x plus 2. And that's going to equal then, these two fractions are going to be my denominator. So x minus 5, a divided by x minus 5 plus b divided by x plus 2. Again, to eliminate our denominators, to eliminate the fractions, we're going to multiply by the least common denominator. So we're going to multiply every single thing by x minus 5 and x plus 2. In this case, x minus 5, x plus 2. X minus 5, x plus 2. So when we multiply these, we can look diagonal and cancel out. In this case, they all cancel out, so I'm just left over with 6x minus 2. X minus 5's cancel out, so I have equals a times x plus 2. And in this one, my x plus 2's cancel out, and I'm left over with b times x minus 5. All right. And again, we pick our excluded values, or we pick what's going to make this equal 0, so we cancel an a out. So anywhere we see an x, we're going to plug in negative 2, because that's going to make this 0. Plug in negative 2. Plug in negative 2. So in this case, I have negative 12 minus 2, which is negative 14. And that's going to equal 0 times a, which is 0. And then negative 2 minus 7 is going to be a negative 7b. Divide by negative 7, divide by negative 7, and I get b equal to be 2. All right, so we found half of it. To find our other half, we got to cancel out our b's. So we're going to pick positive 5 is going to cancel that out. So anywhere we see next, we're going to plug in positive 5. So in this case, I get 30 minus 2, which is 28, equals 7a, positive 7a. And that is 0 times b, which is 0. Divide by 7. Divide by 7, a equals 4. And to finish this thing off, to write our answer, we need to write our two fractions. So plug in 4 for a. So 4 all over x minus 5 plus 2 all over x plus 2. And that's going to equal then our 6x minus 2 all over x squared minus 3x minus 10. So there's partial fractions right there. One more thing to talk about is rational inequalities. Actually pretty simple, all right? Rational inequalities, we're going to try to have everything factored out so we can easily solve this thing. Since this one's already factored out, it's a good example to show you right away. What we need to do is, we're going to draw a number line. And any values at x equals 0, so in this case, what makes the numerator equal 0? So 3 and 4. We're going to put closed circles on that. All right? And anything that makes it undefined, we're going to put open circles on it, so that would make the denominator 0. So at 5 and at 6 would make it undefined. All right? And now the only thing left to do is, what we're going to do is we are going to pick values in each of these intervals to see if it's true or not. So here's an interval. Here's the interval. So I put lines on here to separate it. And here's the interval. Okay? So pick a point over here. So pick 0, let's say. If I pick 0, I get negative 3 times a negative 4. And then I get a negative 5 times a negative 6 squared, so a positive 6. All right. In this case, I have a negative times a negative, which is a positive. So I get a positive divided by a negative times a positive. So I get a negative on the bottom. It doesn't really matter what the answer is. All I'm looking at is the signs, because if it's less than 0, it's going to be a negative value. If it's bigger than 0, it'll be positive. So in this case, I'm going to have a positive divided by a negative, which will give me a negative value. And this one doesn't work. This guy doesn't work, so I put an X there. So keeping that same thing in mind, so we don't have to do a lot of algebra, let's pick a value in between here, say 3.5, in between 3 and 4. Say 3.5. Well, if we pick 3.5, this is going to be a positive value. This will be a negative value. This will be a negative value, and this will be a negative value, but then it's going to be squared, so it'll be a positive value. So my fraction here, I will have a negative, because a positive times a negative is a negative. And I'll have a negative times a positive, which is a negative, and a negative divided by a negative is a positive. So this area right here actually works. Okay? So continue on, and each one of these we have to check. So in between 4 and 5, we're going to have to check that out. All right? So let's clear this thing. So let's pick 4.5. If I plug in 4.5, I get a positive here and a positive here. I get a negative here, and then no matter what, I'm going to get a positive because of that squared there. I get a positive there. So now I have a positive divided by a negative, which is a negative value, which is less than 0. Sorry, whoa, I messed up. I was thinking of greater than 0. A negative is less than 0. I apologize. We want it to be less than 0. Hopefully that wasn't confusing you earlier. So this one actually should have been true. This one should have been false. And this one should be true. My bad. Because for this one, we got a positive value, which would have been bigger than 0. Sorry about that. So this one is true here. This one is false because we got a positive value. This one is true because we got a negative value. And then we're going to pick another value in between here. So 5.5. If I pick 5.5, I'm going to get, let's see, I'll get a positive here, I'll get a positive here, I'll get a positive here, and then always going to get a positive because of that squared. I'll get a positive divided by a positive, which is going to be bigger than 0. This case doesn't work. And again, we have one more to pick, which is bigger than this over here, in this area over here. So say 7. If I pick 7, I get a positive here, a positive here, a positive here, and a positive here. So this is not going to work in this area either. So our final answer then would be the values that work. All right, I get rid of that x because it should have worked. I made a mistake. So we know that x is less than or equal to 3. That is going to work. All right, and we also know between 4 and 5, it's also going to work. So we know that 4 is less than or equal to x. That is less than 5. The difference between this less than or equal to sign and just a less than sign is this filled in circle right here and the open circle here as well. Okay, our last example is a little bit different because it doesn't already factored for you and it isn't already solved. The values in which we test are ones that make the equation undefined and the values where it makes the equation true. All right? So we need to solve here on what's going to make it undefined and what's going to make this thing true. Well, we already know that 0 cannot be an option because 0 times 4 is 0. That's going to make this equation undefined. So we already know one point that we're going to have to put on our graph to check is 0. And I should have put a, sorry. A equals 0. All right. Next thing is what's going to make this thing true. So we're going to go ahead and set this thing equal to 0, and we'll solve. So let's go ahead and get 1/4 a plus 5/8 a minus 1/2 equals 0. So what's going to make this thing equal 0 is also another thing we have to test. So we're going to solve for a. And to solve this, we learned from the last section is we need to get a common denominator, and then we'll just solve the denominator or the numerator. So the common denominator looks like it's going to be 8a would be our least common multiple. So if I multiply this by a 2, I have 2 all over 8a then, since I had to multiply that bottom. This one I don't have to do anything, plus 5. And in this case, I would have to multiply it by a 4a, both the top and the bottom, in order to get a common denominator. So minus 4a, and that would be all over 8a. And then we said again, in order to solve, then we'll have to set our numerator equal to 0. So we'll get 7 minus 4a equals 0. Subtract or add 4a. 7 equals 4a. Divide by 4. Divide by 4. A equals 7/4. So we found two spots in which we have to test. All right, so we have to test a equal to 0, or two critical points, I guess I'll call them. 2 points in which we have to test. Where it equals 0, we're going to put a solid dot. So at 7/4 is going to be a solid dot here. And at a equals 0 is going to be an open dot because it makes the equation undefined. So we're going to make a open dot here at 0. And now again, we just have to test our regions. So let's see. Pick a value. Let's just say -1 out here, and let's test it. So if I plug in -1, I get -1/4 plus -5/8. Is that going to be greater than 1/2 is the question. All right, so again, we need a common denominator here, and that would be a -2/8 plus a -5/8. That's still a negative, be a negative number. So that is not going to be bigger than 1/2. So this is false here. Between 0 and 7/4, I think we can pick 1 there. Would be the easiest one to pick. All right, so let's pick 1, and let's get rid of this stuff here. And let's pick 1. So I get 1/4 plus 5/8. Is that bigger than 1/2? So again, this is going to have to be 2/8. Is 7/8 bigger than 1/2? That's very close to 1. It is. In order to tell that for sure, you can change this over to 8s. This would be 4/8. So we know that 7/8 is bigger than 4/8. So this is true in here. And then we need to pick one more. We need to check whether or not it's true over here. So we could pick 2. Would be reasonable because that's not that value and it's to the right of it. So we'll pick 2. So I would get 1/8 plus 5/16. And the question is that bigger than 1/2? Well, this would be 2/16. Is 7/16 greater than 1/2? Well, to tell for sure, change this to a 16th. So we have to multiply the top by 8. 7/8 is not bigger than 8/16, or sorry, 7/16 is not bigger than 8/16. Therefore, this one does not work. So our solution then is our x is in the middle, everything in between here, right? So x has to be less than or equal to 7/4 because of this filled in dot. And then we also write it as then x would be greater than 0, but it cannot be equal to because of this open circle here. So if you read this from the middle out, it says x is greater than 0, x is less than or equal to 7/4, and that's exactly what this graph shows right here. Our line shows us right here. If we read it from left to right, it says 0 is less than x is less than or equal to 7/4. Hope this helps, and hope it makes sense. See you in class.